2.3 is on algebra and problem solving. So we're going to start kind of learning about story problems and so on, but in order to do that, we need to know what certain words mean in math. So what does more than mean? What does less than mean? And so on. So it says write an algebraic expression for the following phrases. So the sum of 5 and a number. All right.
5 plus
Exactly. So you would just do like 5 plus x or 5 plus n or whatever. 7 more than a number. So you would do like n plus 7, right? You have your number, you add 7 to it, 7 more than it. A number decreased by 2, x minus 2, or n minus 2, exactly. A number minus 56. Exactly. These are very, very easy, right? So this is why it's on WebAssign this time, because they're just going to be quick things that you can put. I won't even make you write things down. All right, the product of a number and 12. Product means multiply, right? So we have the product of a number and 12, so like x times 12. Or you can write 12x, right? Let's use other things besides x. N, you could use y. 12% of a number. How do I write 12% in math class? 0.12, yeah, 0.12.
0.12n.
0.12n, that would work. Do you know why we do it that way? It's because 0.12 is really the same as 12 hundredths. And the word per cent means per 100. Okay, so 12 hundredth. So that's why we do that. All right, the ratio of a number and 5. So we could have like y. What about ratio? What do we do? Y over 5, right? It's a fraction. The ratio is a fraction. Y over 5. 7 reduced by some number. So what do we think? 7 minus x or y, or you can use a, whatever you want to use. A number subtracted from 15. This is where people mess up.
N minus 15.
No.
15 minus n.
All right, Caitlin, why is it 15 minus n? You are correct.
Because like 15 is your number and then you subtract.
Yeah, a number subtracted from 15. So that means you started out with 15 and you subtract the number from that. Yeah, that's the biggest one people will mess up on. And then 5 plus 1/2 of a number. So you're going to have 5 plus half of a number, so 1/2 x. The sum of a number and 5, all divided by 2. So when I say the sum of the number and 5, well, that's going to be a number plus 5, right? And then all of it's divided by 2. So all over 2, like that. All divided by 2. Does that make sense?
Yeah.
You could also have n plus 5, and you could say, oh, I want to divide it by 2, so I'm multiplying by 1/2, right? You could do that as well. Either way. All right, so write a verbal description. So let's go the opposite way. So now we have the algebraic expression, and now we're going to use words to describe it. Okay, so who wants to try this one? You could just say 2 minus, or you could say 3 times a number subtracted from 2. You could say something like that. What's another way we could say it? You guys don't like the verbal description. You don't like the verbal descriptions, I'm guessing. Okay, so let's say you could say 2 minus, right? 2 minus 3 times a number. Notice how it's saying without using a variable, so we don't want to say like 3 times x, right? So that would be one way to say it. You could say 3, the product of 3 and a number, let's say it another way. So the product.
2 minus 3x.
Because you can't use the x. So you can't say 2 minus 3x. You'd have to say like a number. So the product of 3 and a number. Subtracted from 2. You could say that. Does that make sense? So there's lots of different ways that you could say these things. All right, how about the next one? 1/2 x minus 5. How could you write it out using words? Try to do it in a fancy way. You guys just aren't fancy, huh? No one wants to do it in a fancy way here. 1/2 x minus 5. Yeah, Xavier?
Half of the number reduced by 5.
Yeah, that's a fancy way. Good. Half of a number reduced by 5. Good. So you could say a number divided by 2 minus 5. You could say things like that. 5 less than a number divided by 2. All right, so write an algebraic expression that represents the situation. So we did a little bit of this the other day. So the total distance traveled when a person travels 55 miles per hour for h hours. So there's been kind of a movement in math to not use the word per, but to instead say for every, because that makes more sense to students. So when you say, oh, we go 55 miles for every single hour, right? That means after 2 hours, you go 55 times 2. After 3 hours, you go 55 times 3, right? So after h hours, how far do we go? 55 times h. That's it. So the distance is equal to your rate times time. So we went 55 miles per hour for h hours. So 55h. All right, so you often have to figure out like sales tax and so on. So, you know, if you're going to a store.
7% P.
Yeah. So with 7% as a sales tax in Indiana, if you go and you buy a shirt and you're like, oh, I have $20 on me, you can't get the shirt if it's $19.99, right? Because your sales tax is going to be added. So you have to consider that. Okay, so the sales tax is 7%. So Peter said 7%, like 7 over 100. You could write it like that, per 100, right? 7 over 100, or
0.07.
0.07, exactly, for a purchase of P dollars. So 7 over 100p or 0.07p. So that would be the amount of tax that you would add on to your purchase. Okay. What if you guys wanted to do the tax all together and you wanted to find the total amount of the shirt all together? So you could do 0.07p plus the initial, which was p, right? Is that what you're saying? Plus p. Do you guys know a shortcut for that? Yeah, what you could do is you could say, oh, I'm paying for 107% of the shirt. Does that kind of make sense? 100% of the shirt would be that $19.99. And then you add on the additional 7%. So to find the total, you could do like 1.07p. So I do that a lot. Like when I'm trying to figure out, like, especially if it's like a 20% increase or 20% decrease. I do it a lot with decreases. So if I go to the mall and I'm like, oh, this shirt's $20, but it says it's 20% off, then I take $20 and I multiply by 0.8, 80%. Because I'm like, well, I'm really only paying for 80% of the price. All right, so anyway, so a movie theater charges $7.50 for adults, $5 for children. Find the total amount of money charged for A, adults, and C, children. Yeah, Xavier?
7.5A plus 5C.
Exactly. So 7.5 or 7.50A, doesn't matter, plus 5C, exactly. A cash register only has D dimes and Q quarters. How much money in dollars is in the cash register? So this is a little bit different. So for every single dime, what do we have? How much is each dime? It's worth 10 cents, right? So how do I write that in terms of dollars? Yeah, 0.10, exactly. So I have 0.10 for every single dime. So 0.10D, 10 cents for every dime. And how much for every quarter? 0.25Q, exactly. So that is how much money you would have in the cash register. All right, making sense? All right, so you are driving at an average speed of 70 miles per hour. How far will you travel in 6.5 hours? Is this what I'm on? Did I skip something? I did, didn't I? It looks like it's missing, like, part of my picture.
Yeah, you're missing.
I don't know why I did that. All right, so anyway, so what does number 4 say? Where am I? I got it. All right, so number 4 says solve the following problems. And A says the outside dimensions of a rectangular apartment are 50 by 40. So let's draw a picture. So we have 50 feet by 40 feet. And it says the kitchen and living area take up 3/5 of the total apartment's area. Find the total area of the remaining spaces. So what you could do if you had a picture is you could divide that picture into 5 equal pieces. Mine aren't looking super equal, but that's okay. And you could say, okay, well, the kitchen and the living area take up 3 out of those 5 pieces. So we take up that much. So then find the total area of the remaining spaces. Or throwing something. All right. So if you do that, there's 2/5 remaining. We have 10, 10, 10, and 10. We divide it into 5 pieces, right? And then we have this much remaining. So could you find that area without even writing an equation? Sure, you could say, okay, well I have 20 by 40, so I have 800, let me write it out, 20 times 40 is equal to 800 square feet. Okay, so don't overcomplicate things. You can always use pictures to help you solve. There's lots of ways you could do this. So what is another way? Whoops. Another way is to realize,
Square feet. So how much feet?
yeah, it's a square feet. It's a 2. Another way is to find that 50 by 40 and say, okay, well, when I do 50 times 40, I'm going to have 2,000 square feet. That's the original amount. And then Peter knew right away. He said, oh, wait, the kitchen and living room take up 3/5 of the total area. So the rest takes up 2/5, Peter. So we're going to have 2/5 of the 2,000. And you can do it that way. So you get 4,000 over 5, which also ends up being 800 square feet. So you could do it that way as well. So you can draw a picture or you can come up with it using fractions. Boys, stop. Stop. Do I have to separate you? All right, you're driving at an average speed of 70 miles per hour. How far will you travel in 6.5 hours? So we don't have a variable this time.
So would that be 70 times 6 and then divide 70?
So let's think about it. So if I went 70 miles per hour for 1 hour, 70 miles. So that would be 1 hour. What about 2 hours? 70 times 2 is 140. And it kind of follows a pattern. So if I went for 6 hours, then it's going to be 70 times 6, which is 420 miles. Yeah, and so Caitlin's realizing that you're going to add 35. So if you add 35, that's going to be half of an hour, right? So 70 times 1/2 is 35. So you'd get 420 plus 35, 455 hours. So you don't have to have a calculator. You don't have to do like 6.5 times miles. Oh, hours. Oh, yes, thank you, miles. That would be a long time. Epic road trip. Miles, thank you. So you don't have to. I believe it would go to Caitlin, yes. She was the first that I heard. All right, Carson is 6 years old. That's my son. His dad is 30 years older than he is. That's true. All right, so how old is Carson? How old's his dad? And if you divide it by 2, right, that's finding the average of their 2 ages. So add the 2 ages together, divide by 2. So we get 42 over 2. So the average of their ages is 21 years. All right, Maya scored a 90% on the first test and 92 on her second test. If she scores 8% less on her lowest than her lowest score for her third test, what would the average of all 3 tests? So she's going to have 90 and she's going to have 92. And then the last one is 8% less than her lowest score. Yeah, so 82. And then we're going to divide by 3. So let's add them all up. So we have 90 plus 92 plus 82. So let's see, let me do 90, 92, 82, 4. So 18 plus 8, 264. And then divide by 3. So we have 264 and we divide by 3. Let's have 8. We have 24. We're going to have 24 left, so 88. So our average score would be 88. All right. Does that make sense? All right, so all of this we did without writing necessarily an equation, but it's leading to us being able to write equations. So eventually we're going to have really complicated story problems, and we're going to have to put together a mathematical expression, right, set it equal to something, and then solve, okay? So will we be comfortable with doing that? Yeah. All right, and then the last little bit is kind of an introduction to equations. So x was created because it meant a number. Okay, that little x just means a number. So when you read these things, what we're reading is a number plus 7 gives me 12. Well, what number plus 7 gives you 12? 5. Okay, so you guys have seen equations before. You know that you have to keep them balanced. You have to subtract 7 from one side, but you also subtract 7 from the other side. And when you do that, you get x equals 5. And that's because of what you're doing in your head. When you say a number added to 7 gives me 12, what you're really doing in your head is you're saying 12 minus 7 gives me 5, right? Does it make So we're doing the opposite operation. So when you say a number times y minus 3 equals 9, yeah, then that means that the number times y equals 12, right? So we're going to add the 3 to both sides. So we say 4y equals 12. So that means y is equal to 3. Okay. Or this is where people start to get a little confused when there's fractions. Don't let it confuse you. How do we read it in our head? We say half of some number is 8. That number would be 16, exactly. So a lot of people will say, okay, I have half of 8, it's going to be 4. That's not how that works. Half of some number is 8. So what we're doing on both sides is we're multiplying by 2. So we get x equals 16. So we're doing the opposite operation. We were dividing by 2, having something, so we multiply by 2 to get rid of it. Okay? So how about the next one? So x plus 3 divided by 5 equals 6. So a number added to 3, all divided by 5 gives you 6. So what about the number added to 3? What should that equal? All of that should be what? So when I divide it by 5, I get 6. It should be 30, yeah. So what do? We multiplied the 5 over, right? We did the opposite operation. We were dividing by 5, so we get rid of it by multiplying it over. So we have x plus 3 equals 30. And then we say a number plus 3 gives you 30, so we subtract the 3, right? So you get 27. So that's all solving equations is. You just keep doing the opposite operation to undo, right? Undo, undo, undo. So the opposite, so when you see a negative, it means the opposite. So the opposite of a number plus 7 equals 10. That's where it's a little tricky. It's not 3. 3 plus 7 would give 10.
Would it be negative?
It's negative 3, right? Because you want the opposite of negative 3. So we subtract the 7 over first, so I get negative y equals 3. And I'm saying the opposite of y is 3, so y has to be negative 3. In other words, I'm saying negative 1 times y. This is really negative 1 times y equals 3. So you can divide by that negative 1. So I get y equals negative 3. And the last one, if you guys think about it, you don't have to do all the work. You guys should be able to get this immediately. Can anybody get the number immediately looking at this? Yeah, what do you think? What's y? Or what's x?
X is 6.
Yeah, 6. Because are you thinking of it like 2 times some quantity gives you 14? Well, that inside part has to be 7, right? So if the inside part is 7, then x has to be 6, exactly. So we're dividing by 2 first. So we get x plus 1 equals 7, and then we subtract 1, so we get x equals 6. That would be the work behind it. Okay? So a lot of these equations, like, I think a lot of times people will overthink them, right? We're just saying, like, 2 times a number equals something. A number plus 7 equals something. I took it down because it's slow all the time. All right, was that the last little bit? I think that was. All right.